Good day to my supervisor, moderator, and everyone watching this video presentation. My name is Lim Jin, and I'm currently pursuing a dual degree under Segi University. My program is the Bachelor of Information Technology, majoring in Software Engineering. My final year project supervisor is Ms. Haslina. Today, I will present my final year project 1. Before diving into the details, let me briefly introduce my proposed project. My project name is Smart Attend, which is an attendance system that uses multi-face recognition technology combined with IoT devices, specifically the Raspberry Pi. This project falls under the deep learning area, and I will implement a convolutional neural network CNN for facial recognition. In later presentation, I will explain why I chose this algorithm. Next, here is the table of contents, which lists the five main parts that I will go through in my remaining presentation, including the problem statement, project objective, methodology, system design, and finally the conclusion. The inspiration for proposing smart attendance came from observing several challenges in the current traditional attendance method, and I will present three main challenges that were found, all supported by the reference from the research paper. The first issue is the fraudulent or proxy attendance, which means fake attendance. For example, in higher institutions like Segi University, lecture often use roll call, which is calling student names one by one, signing attendance sheet, or sharing QR codes to take attendance. So in large classes, it is possible that some students help their absent classmate by answering roll call or filling in attendance sheet, which lead to unfair attendance record. Thus, the issue of proxy attendance persists in these three attendance methods and is proven by these two references. Secondly, traditional attendance methods such as roll call and attendance sheet are often time consuming. It is because they can only proceed with one student at a time, which wastes valuable class time. Lastly, the roll call can also cause minor issues that might be overlooked. The finding conducted by Fisher and Duggan demonstrate that mispronouncing student names can lead to feeling of disrespect, embarrassment, or exclusion among students. This is further supported by the research conducted by Neja, which highlight that mispronouncing students' name can impact their engagement or even disrupt the learning environment. Another issue with roll call is that the student may miss their attendance when the classroom is large or noisy, or because the lecturer voice is too soft. This can lead to inaccurate attendance record. All these challenges highlight the need for an automated and more efficient attendance system, which inspired me to propose Smart Attend. So basically, Smart Attend consists of two parts, which are the IoT device and the dedicated website. The IoT devices chosen are Raspberry Pi 5 as the microprocessor that runs the Python script for facial recognition, and the Raspberry Pi camera module 3 is act like a CCTV to scan multiple faces in real time and send the result to the Raspberry Pi 5 for processing. Beside the IoT devices, this project also included a dedicated website to manage attendance record. This website will be developed using Code Igniter, a PHP backend framework, Bootstrap frontend framework, language like HTML, CSS, PHP, and JavaScript. Besides, MySQL was chosen as the database management for this project. I chose to use Code Igniter framework instead of plain PHP code because a framework helps to build a clean code structure and can significantly speed up the development process through its built-in library and tools. Next, as I mentioned in my earlier presentation, I will use the CNN, which is a type of deep learning algorithm to detect multiple faces for attendance. CNN is an advanced algorithm that excels at image and pattern recognition tasks. It is capable of automatically extracting facial features with high accuracy. The high accuracy is not just simply a claim, it is supported by research, which I will show on the next slide. The table shown here highlight these three research papers I found on Google Scholar, which all show that when CNN is compared to other recognition algorithms, CNN consistently achieves the highest accuracy. This is why it is chosen for this project. Here are the three project objectives that I aim to achieve at the end of project development. The first objective is to integrate IoT with multi-face recognition technology for automated attendance tracking in higher education institutions. The second objective is to develop a smart attendance system using PHP and Code Igniter framework in a web-based platform. Thirdly, to implement data storage using MySQL for enabling long-term tracking and achieving attendance record. For this project, I have chosen the Agile methodology, particularly the Scrum model, due to its flexible and iterative approach that deliver the small parts of the system in time box cycle called sprint, and each sprint typically take 2 to 3 weeks. There are five main phases in the Agile Scrum. Firstly, for initiation, I will create a product backlog which comprises a list of major features that I want to develop. Secondly, the planning phase involves breaking the previous product backlog into smaller tasks. In Scrum, the smaller task that right now is called user story. In the implementation phase, I will start developing the system using the tools and language that I mentioned before. At the end of each sprint, I will evaluate the progress made by testing system feature, gathering feedback, and making necessary improvement. Lastly, the fully tested system is deployed and presented to stakeholders. In my case, system deployment will include hosting the website so that it can be publicly accessible by others who visit the website URL. Next, let's look at my system design. Before going through the storyboard of my proposed system, I will introduce the type of user in my system, which are the admin, lecturer, and student. Specifically, the admin is responsible for managing users such as adding, modifying, and deleting lecture and student record. They can also view the comprehensive attendance report. Next, the lecturer, besides can be viewing the attendance record and report, they also can manually mark or edit student attendance if needed. For students, they can view their own attendance history. Once the camera successfully detects them, they will receive a real-time email notification to let them know their attendance has been recorded. Subsequently, I will present three main storyboards. The first is from the admin view for managing the class. On the right side, there is a navigation menu with options such as dashboard, user management, class, attendance, profile, and lastly, a logout button. At the top left of the page, there is a breadcrumb navigation for showing the current and previous page, which can be clicked to move between pages. The top right section will display the profile image with username and user role. The admin can add a new class by clicking this button, and here it will show the currently active class info. Note that only one class is active at a time because this project only supports one camera. So below it, a table is provided to show all the classes that have been created before. Each row contains edit and delete option along with the pagination for navigation between different table page. Here, a search field is also provided to filter the class data in the table based on the keywords input. Next, this is the lecture view. The design of navigation menu and breadcrumb is similar, so I won't repeat again. Just the lecture and student will have fewer navigation menu option. The top section of this attendance page display the live camera feed. If a student is not detected, the lecturer can manually mark the attendance by clicking this button. Below is the table listing all attendance record, which can be filtered by class section. An attendance report button is also provided to view the attendance report. So next I will show the storyboard design when clicking this button. The attendance report page is a bit longer, so I have split it into two parts. By default, it will select and show the attendance report for the currently active class, but the lecturer can click on the drop-down button to view the attendance report for other classes. As I mentioned previously, both admin and lecturer can view the attendance report. The difference is just the admin can view all the attendance report for all classes, whereas the lecturer only can see the attendance report for the classes that they taught. At first, the attendance report shows some basics info of the class selected like duration and lecture name. And below it, it shows the three summary card, total number of students in this class, total number of classes held, and the average attendance rate for this class. So when the lecturer scroll down the page, they will see a bar chart that displays the attendance per class section. When hovering over each bar, it shows the exact number of students who attend that class. This chart allows the lecturer or admin to identify attendance trends, such as whether the attendance rate will most likely decrease at the end of the semester. Lastly, there is an attendance history table for the class. So this is the end of the attendance report view. Now it's come to the end of my presentation. In conclusion, this project was inspired by real-world problems in traditional attendance method, such as proxy attendance, the time-consuming process of taking attendance that wastes valuable class time, and even communication issue like mispronouncing the student name during the roll call or the student missing their attendance due to the soft voice of the lecturer. To solve these challenges mentioned, I propose Smart Attend, an attendance system that integrated with IoT devices and a dedicated website to manage attendance. Specifically, the IoT device chosen is Raspberry Pi. Inside the microprocessor, which is Raspberry Pi, will implement the Python script and CNN algorithm to achieve multipass reconnection. And last, just an additional showcase of how the IoT device look like since I have already purchased and assembled the IoT component. This is the Raspberry Pi, and this is Raspberry Pi camera module 3. These are the reference I used throughout my presentation today. That's conclude my presentation. Thank you for listening.